Can you cover a tutorial on carbon micronutrients inputs produce better plants? This is such an amazing topic, right? Let's relate carbon to other things that I think we're all more familiar with. Humic layer, humic layer, humic layer, humic layer, carbon, carbon, carbon. Now let's tie in some other words like amino acids, peptides, proteins, enzymes, cell walls, stems, leaf, flowers, roots, right? All of those things. You've heard me talk on this channel many times how amazing it is when we literally produce something from nothing. It produces a tree, a plant, a fruit, whatever it produces, right? And from a little tiny seed, how does it literally utilize a fraction of the nutrients we actually provided throughout its entire grow? If everything works properly, it's pulling in gases from our environment so that something can be created that was not there previously. What is the one thing that connects it all together? That's carbon. And why is that? Well, first, let's just talk real quick about amino acids. We got into this a couple videos back, but things like hydrogen, oxygen, nitrogen, and carbon. Those are gases, right? But how do those gases attach to a solid environment so that the microbes can take those amino acids and begin to produce enzymes, that those enzymes go and help allow other amino acids to form together to produce peptides, that then when more peptides form together, they produce proteins. And then those proteins are used to create the cell walls, the stems, the leaf, the flowers, the roots, and so on. So the reason why is the carbon has 4 sites that can attach itself to other carbons, or it could attach itself directly to amino acids. Why is that so interesting? Well, you have to think about it that because one carbon and its 4 sites can attach itself to other amino acids, which are gases in our environment, one carbon might have all of its 4 sites filled up except for one little site, and then boom, just another carbon attaches to it, and now it can attach to 2 other sites, so it can combine to more gaseous amino acids, and then it opens up and combines to another carbon, right? And which can then attach itself to other carbons and other amino acids, right? So then it begins to build, it's the building blocks to peptides. And that's what it keeps repeating with carbon, is this structure that keeps recombining with gases, so that when enough of these combine together, it forms the peptides. From there, those peptides start to form more together. And like I said, it creates the proteins. And then from there, we take something that's so tiny that you can only see in a microscope to a point where you can begin to hold it in your hand, because it's a seed, it's the flower, it's a stem, it's root, whatever part of the plant we're describing. So what is carbon? Well, carbon is broken down plant tissue, plant structure. That's all it is. Carbon is the leaves that were broken down, right? It's bacteria. It's anything that's organic in nature, right? Fats, plant tissue, stems, bugs, anything that was living at one point is organic, and that's carbon. And then from there, when it breaks down, it's able to reform back through helping to bind to other carbons that, once again, go back to peptides, proteins, stems, flowers, roots, right? So why is your humic layer, because that's where I started off this conversation at the beginning, why is your humic layer so important? Well, that's where everything's allowed to get started. Your peptides, your proteins, your stems, your roots, and so on. If you don't have a strong humic layer that can hold the minerals that are essential for bacteria to create coenzymes, that's why I'm always pushing BAM. That's why I'm also always pushing the drops of balance, because those things are essential down the chain to produce more complex peptides, which form proteins. So initially, in the very, very beginning, let's say you're using bacteria that help fixate nitrogen. At that point, they're helping to fixate nitrogen on carbon. And then from there, when you have the nitrogen finally combined to the carbon, that's when the bacteria go in and they are able to start to produce certain enzymes based upon the minerals that are in the environment. Obviously, you also need water, because everything has to be water soluble. If it's not water soluble, bacteria can't do their job. So it's really interesting when you start to get into carbon, and having a strong humic layer is so essential on, we're talking about the building blocks, right? The very first steps to where everything else is allowed to take off and become what we actually see, hold, smell, and enjoy on a daily basis. Have a great grow, and please remember to like, share, subscribe.